Hello guys, welcome to another episode of the Supermileage show. Let's get started. So what's in store for today? Under the EV news section, we'll be bringing about some interesting EV news from this week. Moving on to the tech section, you'll be having a hands-on session with a commercial motor controller. Following that, we have the safety tips where I'll be briefing you about some of the measures that you guys could follow when you're driving an electric vehicle, especially in cold climate. So Bajaj Chetak is planning to come back to the Indian market after such a long time. But there's a difference this time. It's not going to come out as an ICV, but it's trying to come out as an electric vehicle. And first impressions have actually made sure that there's a lot of culture and noise around the same. It is priced close to almost a lakh, and it claims to give us a range of about 98 kilometers. I mean, all of this sounds interesting, but we'll have to wait a bit more to see these on the Indian roads. Why is that exactly? As all of us know, this pandemic has shut down almost everything, and it comes as a no-brainer that most of the components that make an electric vehicle come in from China, at least for now. So, and also considering the recent trade-offs between India and China and the difficult norms that the Indian government has put in place, it's difficult for any company, leave it Bajaj alone, to source these components. So what Bajaj is trying to do is, they've stalled all the bookings for now, so that until and unless they can localize all of the components and make sure they get them or source them from Indian manufacturers, they are making sure that they're not releasing any Bajaj Chetaks. Moving on, let's talk about the Hyundai Motor Company. Why exactly are we talking about this? So the Hyundai Motor Company has actually started exporting separate fuel systems. So not as a complete fuel cell electric vehicle, but separate fuel systems to Europe. To be more specific, they are reaching out to firms in Switzerland, wherein these fuel systems are not actually used for automotive purposes. That comes as a shocker because Hyundai Motors actually, since the start of 2000, they've been sourcing fuel cell electric vehicles. And it's been a really good move with the iX35 model, which was widely accepted, and then 5 years later when the Nexon came on. It's been a really fruitful journey for Hyundai Motors, and it's really good to see them venture into new waters wherein they're actually sourcing their fuel systems for non-automotive purposes as well. So that makes Hyundai a really great company because it's not only sourcing fuel cell electric vehicles but also fuel systems separate. Moving on, Nissan recently celebrated a really huge milestone. What is it? Actually, in one of their plants in Sunderland of England, they made sure that they could sell their 500,000 Nissan Leaf vehicle. I know, right? 500,000, that's a really big number. But it comes as a no-brainer because Nissan Leaf is such a popular electric vehicle. Given its specifications, the range that it offers and the comfort that it offers, it is really not shocking to see that Nissan Leaf has such a great target, given that the vehicle was released just a decade ago. So talking about this plant in particular, if you see, it has produced close to 1,35,000 vehicles. And if you see Nissan Leaf's contribution to the ecosystem in general, it has reduced tons of carbon footprint. And so that's a really great move.
Hey guys, today we'll be taking a very quick look at a commercial e-bike BLDC motor controller. Now we can't show you an actual controller because it's confidential. So what we have here is a 48 volt 20 amp sine wave e-bike motor controller. Now this is how the actual board of the controller in your e-bike will look like. I will be going through some of the most important components of a controller today. First, let me tell you what these wires are. These are the battery wires. This connects the battery pack to the motor controller. Do you see these two huge capacitors? These are rated at 63 volts and 470 microfarad. Now, these are called decoupling capacitors. We've come across capacitors being used in situations where there might be a sudden need of extra current. That's kind of what these two capacitors do. Now, these thick wires are, well, thick. And what do thick wires have? Inductance. Inductance is a function of loop area, which in turn is a function of cable length. So, longer these cables, the higher the inductance, and inductance lags current. So when the controller asks for short bursts of energy, due to the inductance, the current will be, in quotes, sluggish. That is what is counteracted by these two huge capacitors. These capacitors store some energy and hence will be able to meet the sudden energy demand. These are the 5 Hall sensor wires. If you don't know or can't remember, just go back and watch episode 05, which is on motors. I've discussed about Hall sensors in general and why 5 wires, etc. These are the 3 throttle input wires: positive or VCC, ground and signal. And the signal wire outputs a range of voltages from 0 volts to 5 volts, which will be proportional to the acceleration. 0 volt being no acceleration and 5 volt being 100% or max acceleration. The other bunch of wires are some add-ons you get with commercial controllers. This is the microprocessor, STM32 by ST Microelectronics. This is a 32-bit ARM Cortex processor with 64 pins in an LQPF64 package or low-profile quad-flat 64-pin package. This is one of the package type in SMD components. These are the 3 phase wires and these are the MOSFETs. As we discussed previously, the phases are powered using the MOSFETs and these MOSFETs are arranged in an H-bridge configuration. For any BLDC controllers, you will need 6 MOSFETs. Now here we have 12. Why? It's just so that lower rated MOSFETs can be used instead of using a big one. We even find controllers with 18 MOSFETs in the market. What you see here is a heatsink. MOSFETs can get really hot, and I mean really hot. This is another reason why commercial controllers use lower rated MOSFETs. When lower rated MOSFETs are used, the heat generated by each MOSFET will be less and hence will be easier to dissipate. This will be screwed on to the outer case, which is basically a larger heatsink. And before screwing on, some thermal paste will be added here to ensure full contact to the outer case, just like in a CPU of PCs or laptops. That is essentially all I can talk about commercial controllers. If you want to know something, then please drop them in the comments below. Thank you all for tuning in today. I appreciate the time. Take care, stay inside, see you all in the next one. Bye bye.
Most people complain that under cold climate or extreme temperature that's on the lower side, the electric vehicle would give a below par performance, and it's actually true. That's because the battery's performance is directly proportional to the temperature, so higher temperature ranges, then the battery gives you better performance. So if you see that way, then what is the solution for this? There's actually a lot of research and studies going on this field. I will share some of the measures that one could follow, when you're driving in cold climate and especially in an electric vehicle. So the first thing is that make sure you use these pre-timed heating systems that are available in most electric vehicles today. So when your electric vehicle is getting charged, make sure that you're heating or supplying enough heat to your battery at them so that to keep it warm, and at least you'll have a better start to the journey. And one more thing is make sure you're driving in the eco mode, or basically making sure that you're not accelerating that much, because see, everyone knows that as much you accelerate, the battery drains that quicker. So try to keep that in check. One more thing, try to plan your trips in and around these fast charging stations so that even if your battery is getting drained quick, you could also have these top-up charges on the way. Try to also, as much as possible, reduce usage of the HVAC systems, because reports suggest that as much as 50% of the battery draining under cold climates is actually due to the cabin heating and other stuff. So make sure you limit HVAC usage as much as possible. And if the resources permit and you have all the time, then try to winterize your vehicle so that it's more EV friendly, and you'll have better performance as well. Because if you see the reports, it states that if there's a electric vehicle that is giving you 100% electric range under normal conditions, then under cold conditions it would reduce 12%, so it would give you somewhere close to 88% electric vehicle range, and that would decrease even further when you're using these HVAC systems. So that is why I mentioned that try to keep that in check so that you have a better range and a smoother ride. That's it for today, guys. Thanks for tuning in. Hope to see you in the next episode with some other exciting new content. Until then, think, sketch and execute.